Okay, this is the stoichiometry roadmap. So if after we go through this, if you're still struggling with the process, you can always come back to this video lesson and write that down somewhere or kind of follow that if you want. I don't put that in the notes because, quite frankly, especially for the pre-AP students, it's a crutch. It's better to just learn the process because you don't get to use that on the test. It's better to just learn the sequencing, okay? And if it goes back to when we did dimensional analysis, if you will let your units be your guide, then your units will tell you what you need to do next, okay? All right, so let's go. So the mole ratio, we're going beyond that. Remember, 1 mole of any substance is equal to the molar mass. Remember molar mass? Who remembers molar mass? Okay. Molar mass is where we are adding up the masses in the equation and the formula. Okay. For instance, if I was doing the molar mass of water, I would do 2 times 1.01 for hydrogen plus 16 for oxygen, and my molar mass would be 18.02 grams per mole. Does that ring a bell? Okay. All right. So, always going to start with the balanced equation, and then basically this will tell you through the steps, but I'm going to just manually tell them to you. You start with the balanced equation first. Always, always, always. I can't stress that enough. Okay? Then you identify in the problem what's the known. What are they giving you? Because we always have to start with that. Okay? It's the only thing we can start with. Then you want to identify what the problem is asking for. Okay? So you know what you're looking for, because that's going to be your mole ratio. The moles of what's given to you is going to be on the bottom of the mole ratio. The moles of what they're asking for is going to be on the top of the mole ratio. Okay? And so any kind of conversions we need to do around that, it's going to have to go through the mole ratio. Okay? So let's get, and then you're going to use your molar masses to convert, and then check your answers to make sure all the units are canceling. So all that seems like I'm just talking in a foreign language until I show you some problems. So let's work some problems. Okay, so here's the first one. I'm sorry I don't think it got that way on your paper, but it did on my slide. I have copper hydroxide decomposing to copper oxide and H2O. So to make this easier, I'm going to put this over here so we can see it all together. So first thing I need to do is check to see if it needs to be balanced. And it doesn't. Okay, sometimes you get lucky, and everything's a 1-to-1 ratio. Okay. So first thing we did was check to see if it's balanced. The given is 6.59 grams of copper 2 oxide. Okay. So ultimately how many unit sig figs am I going to put my answer in?
3.
Okay. It's always a good idea to just do that first, and then you have that in your head. So we're going to start with 6.59 grams of copper hydroxide. And I'm just going to tell you, draw a big grid, because we're going to need lots of steps. For the mole ratio.
Okay.
When we get to the mole ratio. Yeah, you always start with what they gave you on the top.
That's what I thought.
Yeah, no, I was talking about the mole ratio, okay? When we're doing the mole ratio, the moles will go on the bottom, okay? But we can't go straight to the mole ratio right here because we're in grams. And how do we go grams to moles? What do we do? Convert, yes, but how do we convert? What were those units on molar mass again?
Start with A.
I just wrote it down on the What? Not AMU. Grams per mole. The molar mass unit is grams per mole. So we convert from grams to moles, moles to grams. We're not using it in here.
We don't use it in.
Not in this unit, no. Okay? Okay? Unless I'm asking you about atoms or molecules, no. We're going to mostly deal with grams and moles. Again, I can't go in the lab and weigh out atoms. Okay? So I'm going to need the molar mass of copper hydroxide. Okay? So we'll jot it down up here. I don't have anything today. Okay. So copper hydroxide. I'm at the top of the thing. It won't let me write. Okay? So copper is 63.55 plus I have 2 oxygen. So I do 2 times 16. This is not working out at the top of this. Plus, I have 2 times 1.01 for hydrogen. So I add all that together, and I get that the molar mass of copper hydroxide is 97.57. So it goes on the bottom. And that's per 1 mole. Okay? Now I have converted my grams to moles, so now I can use the mole ratio. Okay? So now I can use the mole ratio. Remember, the mole ratio is how we get from what's given to what we're looking for. So I'm going to do mole of copper hydroxide on the bottom, and I'm looking for how many grams of copper to oxide. So I'm going to do mole of copper oxide on the top. I need to learn to write smaller on this thing, don't I? Okay. All right. I go look at my balanced equation and see what the coefficients are. I have a 1 and a 1, so I just put my 1 and my 1 there. Now my moles of copper hydroxide are canceled out. Okay. But this problem, God bless you, this problem asked for grams of copper oxide. So now I need to go from moles to grams. So I'm going to need the molar mass of copper to oxide. Okay? So I'm going to put I'm running out of room, 1 mole of copper oxide on the bottom. And then I'm going to add the molar mass up of 63.55 plus 16 for oxygen. And it's 79.55. I promise to write smaller on the next one. And it's just grams. Okay? So now my mole of copper oxide cancels. And I have grams of copper oxide, which is what I'm looking for. It's ultimately what I asked for. So I multiply the top and divide by the bottom. Multiply the top and divide by the bottom. Okay? Whatever your personal preference is for that, if you want to multiply everything on the top, write that down. Multiply everything on the bottom, write that down, and do one last division problem, you can do that. Remember, on the calculators, I have that N over D button. So you literally can do that button, punch in all the top numbers times, and then on the bottom, put all the bottom numbers times, and hit equal, and you'll get the answer. Okay? Or I think you have that on your graphing calculators too. That button somewhere, I just can't remember where. So when I do all this math, and I put it in the correct number of significant figures, I get an answer of 5.37 grams. Okay? 5.37 grams. Any questions? Any questions?
Nope.
I know, the first time you see it, it's confusing. We'll do a couple of more. Okay? Let's go to the next one. This says if excess sulfuric acid reacts with 30 grams of sodium chloride, how many grams of sodium sulfate are produced? So what is the first thing I need to do? Balance the equation. So how am I going to do that? What are my coefficients? So 1, so I don't, 2. Why do I keep forgetting to do that? Okay. I know, I do it all the time. Because you have to hit a button. 2. Okay? So now it's balanced. Okay? Now it's balanced, so now I can, all right? So I start with what's given to me. I have 30 grams of sodium chloride. Okay? 30 grams of sodium chloride. Okay, I need 3 significant figures in my answer. So I need to get rid of grams of sodium chloride, so I immediately put that unit on the bottom. Okay? And I will tell you that it's 58.44 grams of sodium chloride. is its molar mass in 1 mole. Okay? Now I have converted to moles, so now I can use my mole ratio from the balanced equation. So I say moles of sodium chloride on the bottom, and I'm looking for how many grams of sodium sulfate. So I will put moles of sodium sulfate on the top.
Wait, why isn't it 2 moles of sodium?
I haven't gotten there yet. I have you write down the mole ratio. Now let's go look at the balanced equation. So I go to moles of sodium chloride, and it's right there, so I put a 2. Moles of sodium sulfite has no coefficient, so that's a 1. So now my moles of sodium chloride will cancel out. But I'm trying to get to grams of sodium sulfite, so I'm going to put mole of sodium sulfate. I said sulfite, sorry. And I'm going to put grams up here. And now I'm going to go calculate the molar mass of sodium sulfate. Okay? So I go and calculate that molar mass, excuse me, and I get 142.05. Okay? So now my problem is set up, so now I can go do the math. So I multiply everything on the top, divide by everything on the bottom. Again, your personal preference on how you put that in the calculator. Okay? That's why on your notes I went ahead and gave you the answers in your practice problems so you can see, did I do it right? Okay? That's why I did that. And so I need 3 significant figures, so my answer is 36.5 grams of sodium sulfate. So those two are the mass-to-mass problems. They're the longest problems. Well, when we do limiting reactants, they're not the longest, but it's the longest conversion. Okay? The next one is if I have volume. Okay? And if you'll go back to your stoichiometry steps and look at number 4, someone tell me what is the conversion factor if I'm dealing with volume? How many liters? 22.4. That is if we are at STP conditions, which we'll learn when we get to the gas laws, stands for standard temperature and pressure. Assume all of these problems are at STP conditions, so you're going to use the 22.4 liters per mole whenever we're doing those conversions. Okay, so instead of using molar mass there, we would use that volume conversion. Okay, so this one wants to know how many liters of oxygen are used to produce 75 grams of sulfur trioxide, and it gives you the conversion. So first things first, balance the equation. Okay, and those coefficients would be 2, 1, 2. So it's going to have a 2 here, a 1 there, and a 2 on the last one. Okay. So this time we are starting with 75 grams. We need 3 significant figures. So we start with 75 grams of SO3. Whatever unit I write down, I need to get rid of in the next step. So it's going to be grams of SO3 per 1 mole of SO3. So I need to calculate the molar mass, excuse me, of sulfur trioxide, and that works out to be 80.07. I don't know if you can see that very well. Okay, now that I have gotten rid of grams, I'm in moles, so I can use my mole ratio. So I need to get rid of moles of sulfur trioxide, so it's going to go on the bottom. And I'm trying to get to oxygen. So I'm going to do moles of oxygen on the top. Now I go to my balanced equation. SO3 has a 2 in front of it, so it goes right here. Oxygen has nothing, so it's a 1. So I cross out my moles of SO3. Okay? Now, on the last 2 problems, I did molar mass here because I was trying to get to grams, but I'm trying to get to volume, so I'm going to use this conversion factor right here. So I'm going to say for every 1 mole of any gas, not just oxygen, of any gas, it's 22.4 liters of oxygen. Again, that's for any gas at STP conditions. So now my moles of oxygen cancel. So I do that math, and with 3 significant figures, multiplying the top, dividing by the bottom, I get 10.5 liters of oxygen. The only difference was that instead of going to grams, I was going to liters. And then I have one more example for you, and then we're done for today. Then I suggest working some left side to see if you can get the right answer, since you know those answers are there for you before you start on your worksheet. It's not due till Monday. The worksheet's due Monday. Because tomorrow we're going to be doing, yeah, this is pre-AP worksheet's not due till Monday. Pre-AP worksheet is due Monday. Okay? All right, so last example, I have how many grams of oxygen is used when 85 moles of ammonia reacts. Who wants to balance that one? Yeah, this one's kind of hard. I'm just going to give it to you. Huh? Very good. 4, 5, 4, 6. That's good. 4, 5, 4, 6. That's a little bit difficult one to balance. Okay? So this time we're starting with moles of ammonia. Okay? So we're going to do one less step. We only need 2 significant figures in our answer. So we start with 85 moles of ammonia. I want to get rid of moles of ammonia, so it goes on the bottom. And I'm looking for how many grams of oxygen. So I put moles of oxygen on the top. Now let's go to my balanced equation and get those numbers. Moles of ammonia is 4. Moles of oxygen is 5. So now moles of ammonia cancels out. It's wanting to know grams of oxygen. So that means I'm going to need to use my molar mass. So I'm going to have 1 mole of oxygen. And what is the molar mass of oxygen gas?
16.
No, not 16. Oxygen gas, diatomic. See that little 2 right there? So it's 32. It's 32.
When you use the balance equation, when you don't use the balance.
You always use the balance equation for the mole ratio step, which is right here. It's going to be in the middle of your problem. It's how you go from what's given to what it's asking for. That's when you use the mole ratio. The fact that we were already in moles, we could go straight into our mole ratio. Okay? When I was in grams, like the previous problems, I had to go grams to moles, then go to my mole ratio. But if I start out in moles, I can go straight into my mole ratio. Okay? And then I need 2 significant figures, so when I do that math, I should get 3,400 grams of oxygen. And that would be my answer. Okay? So I suggest before you try to work the problems on the worksheet to do your left side activities, especially since the answers are there so you can see if you're doing the right process. Any questions?